In the last video, we started to look at inequalities. We looked at some of the notation, we looked at writing inequalities, we looked at finding integer values that satisfy inequalities, and we also looked at representing inequalities on a number line. In this video, we're going to look at solving inequalities. When we have an inequality, we can use similar techniques to solving these as we would an equation. It's hugely important to appreciate that inequalities and equations do differ, and we did introduce that in the last video. So let's start off now with an equation. So 2x is equal to 4. This is an equation as we've got the equal sign here. An inequality, for example, might be 2x is greater than 4, or we might have that 2x is going to be equal to or less than 4. We might have 2x is equal to or greater than 4, and then the only one that we'd have left is 2x is less than and strictly less than 4. So this is an equation and this is an inequality. This one is, and that one is. So what would we do to solve this equation? The answer is divide both sides of the equation by 2, and that would give us that x is equal to 2. We would use exactly the same technique here. As we look at later examples, if we're multiplying or dividing an inequality by a negative number, the sign will change. But for now, we can see that if I wanted to solve any of these, I would divide both sides of the inequality by 2. So x is going to be greater than 2. We've got now that x would be equal to or less than 2. We've got that x would be equal to or greater than 2. And we have that x would be strictly less than 2. So that's just solving an inequality. Often students who are not comfortable with them do put in the equal sign and then switch it back later. I think doing that is an option, but it's incredibly limiting in terms of your understanding of inequalities and also if there's a negative number somewhere in here. So let's start off. We've solved one inequality. Let's go for another one. So 3x is equal to or greater than 15. All we need to do is divide both sides of the inequality by 3, and that will give us now that x will be equal to or greater than 5. So we've solved this inequality. At this stage, you might be asked to state 3 integer values that satisfy that inequality. If you were, we could say that that could be 5, 6, and 10. We looked at that in the last video. Solving an inequality doesn't mean you have to find integers. It just might be a part A, so this could be part A, solve the inequality, and part B could be list 3 integers that satisfy the inequality. Okay, let's look at another one. Let's do now 1 plus 2x is going to be less than and strictly less than, and we'll go for 15. So if we had an equation that was 1 plus 2x is equal to 15, the first thing we would do is subtract 1 from both sides. So that's all I'm going to do here. I'm going to subtract 1 from both sides of the inequality. This is going to now give me subtracting 1. We've got 2x is going to be less than 14. So what I'm looking to do, as I would with an equation, is isolate the term in x. I would then divide both sides of the inequality by 2. No sign change because we're dividing by a positive number, and that would give us that x is going to be less than 7. So that solves the inequality for us. Okay, let's do another one, and this is where the negatives kick in. So let's say we've got 4 minus 3x, and we'll say that this is going to be equal to or greater than negative 17. What I want on one side of the inequality are the x's, and on the other side the numbers. What I'm going to do at this stage is add 3x to both sides of the inequality. So plus 3x. If I do that, I'm going to have 4 is equal to or greater than 3x. Then I'm going to have now minus 17. You can write it as minus 17 plus 3x. I want the x's by themselves, so I'm going to add 17 to both sides of the inequality. So adding 17, I'm now going to get 21, and 21 is going to be equal to or greater than 3x. I want 1x, so I'm going to simply divide both sides of the inequality by 3, and that will give me that 7 is equal to or greater than x. So if we were asked for integers that satisfy this, if we wanted to, we could say 7, 6, 5, 4, 3, and so on and so forth. Okay, let's look at this another way. What I'm going to do to begin with, just rewriting it, is 4 minus 3x is going to be equal to or greater than negative 17. This time I'm going to subtract 4 from both sides of the inequality. That's going to leave me that negative 3x is going to be equal to or greater than negative 21. At this stage, I'm going to divide both sides of the inequality by negative 3. So dividing both sides of the inequality by negative 3, what I'm going to have now is the following. I'm going to, and I'll write this out step by step, I'm going to have x is going to be equal to or less than negative 21 over negative 3. So this gives me now that x is going to be equal to or less than positive 7. If we look, these are exactly the same statements. And we can see now 7 is equal to or greater than x, 7 is equal to or greater than x. The reason I've done it this way now is to show that the inequality sign changes. You can see by manually moving it now, from here we've gone for this approach, but when I divide or multiply this inequality by a negative number, we need to change the sign round. So just be careful when you're dealing with these. Later on in your study, some of these will be quite well hidden, so just be a bit careful with them. So hopefully you can see that these two statements are exactly the same. So for example, now let's put in a number for x. Often if you're unsure, just put a box there. Find me a number now that's 7 or less. Well, 1, that works. If we look at this one, we can say now find me a number that's going to be equal to or less than 7. We can see 1, and that satisfies the inequality. Okay, let's try another one. Let's go for this one. Let's say we've got 3, then 1 minus x, and we'll say that that is going to be equal to or greater than x plus 6. So what we have here, similar to an equation with unknowns on both sides, we have to go ahead, expand the brackets, and then look at solving this inequality. So expanding the brackets, 3 times by 1 and 3 times by the negative x will give me 3 minus 3x is going to be equal to or greater than x plus 6. At this stage, I'm going to add 3x to both sides of the inequality. So I'm going to have 3 will be equal to or greater than x plus 3x, which is going to give me 4x, and then I'm going to have the 6. I'm now going to subtract 6 from both sides of the inequality. That will give me negative 3, and that's going to be equal to or greater than 4x. I just want 1x, so I'm going to divide both sides of the inequality by 4. This is a negative number, but I'm not dividing the inequality by a negative number, so it'll be negative 3/4 is going to be equal to or greater than x. So that's what we have. Again, if you wanted to state integer values, you could say now that negative, so this is, if you wanted, you could even graph it up. Let's go ahead and graph it up. What we can do is, let's locate this, and we'll just do this. So this is just branching off from the last video. So what we've got then, 0 here, we locate what we call our critical value of negative 3 over 4, and this is inclusive, and this is going to be now the following. We're going to say that all values to the left. So x is some number that is at most negative 3/4. So if we think, we could have now negative 1, negative 2, and so on and so forth. So that's a bit more of a, slightly more advanced one from the other ones. Okay, let's look at another one. Let's look at double inequality. So 3 is going to be less than, and we'll go for, let's make this nice and straightforward to begin with, 3x, yet in turn 3x is going to be equal to or less than 12. So we've got a double inequality here, and we looked at some of these in the last video. What I'm going to do is divide each part. I've got 1 part, 2 parts, 3 parts by 3. I want now just x here. So if I do that for each part, 3 divided by 3 is 1. So we'll have now 1 is less than x. Then in turn now dividing the 12 by 3, that gives me 4. So that will solve our inequality for x. So if you're asked to state all of the values that satisfy this inequality, we could say that that would be 2, 3 and 4. We know that 1 is not included, 4 is included, so these are all of the integer values. So two different parts of the question. You might be asked to solve this inequality and then state all of the integers that satisfy it. Let's do another one. Let's say we've got this time 4 is going to be equal to or less than x plus 1, yet in turn x plus 1 is strictly less than, let's go for, we'll go for 11. What I want to do is solve for x. So the last time I divided by 3, I simply need to subtract 1 from each of the 3 parts. So 4 minus 1, we're going to get 3. Then we'll have x, as we've subtracted 1, and then we'll have 10. So all I've done is subtracted 1 from each part now of the inequality. Again, if you're asked to list the integer values, you're going to have 3, 4, 5, 6, 7, 8 and 9, as 10 is not included. It's a strict inequality. Let's have a look at another one. Let's say we've got 9 and then we'll have, let's go for 2x plus 1, and we'll say from there that this will be less, and we'll go for 21. So I'm now going to subtract 1 from each part of the inequality. That will give me 8, then we'll have 2x, and then we will have 20. I'm now going to divide each part of the inequality by 2, and we're going to have 4. We will have 1x, and we will have 10. So that is solving it, as you would with an equation. All I've done at this stage is undone this. I've done the inverse. I've subtracted 1 and divided by 2. Let's try something slightly more challenging. Let's go for negative 3 is going to be equal to or less than 1 minus 2x, and in turn this is going to be less and strictly less than 31. What I'm going to do at this stage is subtract 1 from each part of the inequality. So we're going to have negative 4, we're going to have now negative 2x, and then we're going to have positive 30. At this stage, I'm going to divide through the inequality by negative 2. Remember, that's going to see the signs change. So if I divide negative 4 by negative 2, I'm going to have positive 2. Then the inequality sign changes. I'm just going to have x. If I divide now 30 by negative 2, I'm going to get negative 15, and we're going to have the sign change round to negative 15. If you really wanted to, you could rewrite this as negative 15 is less and strictly less than x, yet in turn x is less than or equal to 2. That might be a nice way of seeing it. And now you can probably see why, in this situation, we're going to have to switch your inequality sign around. If I didn't, it makes no sense. If we had written it now that 2 is going to be equal to or greater than x, yet in turn it's going to be less than negative 15, that just doesn't make sense. The number we're looking for is going to be 2 or more, so that would be 2, 3, 4, 5, dot, 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 right the way up to positive infinity. And then this one right here, yet at the same time it has to be less than negative 15, so it's got to be negative 16, negative 17, dot, 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 right the way up to negative infinity. Now, there's no number that satisfies both of those. So hopefully you can see dividing through by a negative or multiplying by a negative, we change them over. Let's just finish with one more. Let's go for 3x plus 1 divided by 4, and we'll say that that's going to be equal to or less than, and we'll just go for x minus 3 over, and we'll go for 3. Okay, at this stage what I need to do is solve. I've got fractions and I'm simply going to multiply it by the lowest common multiple. The lowest common multiple of 3 and 4 is 12. So multiplying both sides of the inequality by positive 12, that means we're not going to get a change of the sign. If I think about this now, just multiplying this one by 12, that's going to give me 3 lots of 3x plus 1 with the fraction cancelling. And that is going to be less than or equal to 4 lots of x minus 3. Okay, so we're going to have 9x, expanding the brackets, plus 3 is going to be equal to or less than 4x minus 12. I'm going to subtract 4x from both sides of the inequality, 5x plus 3, and that's going to be equal to or less than negative 12. I'm now going to subtract 3 from both sides of the inequality. That's going to give me 5x is equal to or less than negative 15. Dividing both sides of the inequality by 5. 5 is a positive number. That's going to give me negative 3. So we can say that x is going to be equal to or less than negative 3. So all I've done from there is solved an inequality in a very similar way to solving an equation. But you'll do these later on. There is a video on solving equations with fractions in. The same technique is used. We just have to be careful if we've got a negative number when we're multiplying or dividing. Okay, let's just finish off with a wordy question. We're told Petra wants to buy some cakes. The cakes cost 43p each and she has £2.36 in her pocket. Find the maximum number she can buy and work out what change she'll have left if she buys that amount. The first thing that strikes me here is that we're working with different units, 43p and 236p, or £2.36. What I'm going to do is write an inequality for this. And what I'm going to say is let x, so x, be equal to the number of cakes. You might want to call it n, so number of cakes. So let's write the inequality, solve it, and then look at the change that she has. So what we can say then is 43x. So for example, if I bought 1, it would be 43p. If x was 2, the number I bought was 2, it'd be 86. This must be equal to or less than 236p. So I've now got the same units. So if we look at this, if the number of cakes was 1, 2, 3, and 4, there's going to come some point. And that point, if we're going to solve this, is going to be when x is going to be equal to or less than 236 over 43. So let's work this out now. So we've got 236 divided by 43, and that now gives us 5.488. So what we can say then is x must be less than 5.488 ... and so on and so forth. So let's now think about this in context. If we look at this, it's saying that x must be less than this value. Cakes are discrete. So what we can say then is the maximum, so max number, is going to be equal to 5. The value of x must be less or equal to, and of course we can't go ahead and buy 5.488 cakes, so we'd have to say that it's going to be 5. So if it was going to be equal to or greater, we'd have to say that it's going to be 6, as these are whole number values. So all we need to do then is 5 to work out the change. 5 times by 43, that's going to give me 215p. So we can see that the change from this is going to be 236 minus the 215, which is going to give us what, 21p change. So 21p change, and she's bought 5 of them. So that is writing an inequality. And at the moment you might see that as a bit overkill and unnecessary. But when you come on to more challenging examples where we have lots of different constraints, then it is important rather than just setting up an equation as such. So there we go, 21p change, she can buy 5, as the number that we can get has got to be less than about 5.5, therefore it's got to be 5. So a video on solving inequalities. They are not equations. The techniques are very similar, other than when we're dividing or multiplying by a negative number. In the next video, we will look at shading regions, or if you like, graphing inequalities.